This is video tutorial 3 for the users of DeepKymoTracker. Here you can see the title page of DeepKymoTracker. In this tutorial, we are going to discuss step 3, executing correct tracking. Step 3 is the core part of DeepKymoTracker. It is in this step where the automated tracking, segmentation, and division detection happens. So let's start by pushing this button. We are in the tracking page now. As you can see, there are 3 windows here. The middle window is the main one because the tracking will take place in real time. And it is in this window where the tracking results will be appearing frame after frame. Your task as the user will be to visually monitor the progress in this window. And should you detect any tracking errors, you're supposed to pause the tracking by this button, make the necessary manual corrections using these tools, and resume tracking by pushing this button. But we are going to discuss it later in more detail. Note that you can correct only tracking errors here, such as listed here, editing cell IDs. It's for correction of cell swappings, ID swappings. Also, you can edit missed divisions here. You can add new cells which emerged out of nowhere. And finally, you can delete dead cells. As for the manual segmentation correction, it can only be conducted at the next step, step 4 of the algorithm. So while monitoring the tracking process in the middle window, you will need to concentrate on the above mentioned tracking errors only, ignoring segmentation imperfections completely. So the middle window is for the current frame during tracking. As for the left window, it is designated for the previous frame. Even though the previous frame is mostly needed during the manual correction, but it is helpful to see during the tracking as well. That is why the left window has been programmed to show the previous frame along with the current frame during real-time tracking. Finally, the right window is programmed to show you the lineage tree for the checked cells, which will be plotted dynamically. After execution is finished, the algorithm, you're supposed to push this button, and the algorithm will generate Excel files with numeric information about each tracked cell, such as area, circularity, etc., for each frame, and a number of files and folders with the usual information. We will go through the output folders at the end of this tutorial. So let's start by pushing this button. Now the file menu opens and you should navigate to One Well Movie. Here it is already. So the name of our movie is One Well Movie Tutorial. Let's choose it and click this button. What happened here? The background color of the window has changed all of a sudden. Why is it? It is actually another window with the black background, which has just popped up. And the reason you need this additional window is that we need to prepare our current movie for tracking by manually assigning some initial parameters. And this window provides you with tools to do that. Let's call it the preparation window. As you can see, the 3 windows show all the 3 channels of the movie. This is the bright field channel, fluorescent, green fluorescent channel, and red fluorescent channel. Once again, you can check that the number of fluorescent images is equal to number of bright field images, which is the case for our current movie. So this is a good thing. As was mentioned in the previous tutorial, a DeepKymoTracker needs only bright field and green channels to perform tracking and segmentation. So the number of red frames doesn't matter. You can also inspect each frame if necessary using this slide bar. It's very helpful, very convenient way of looking through the movie. However, the main purpose of this window is to enable the user to manually set up some parameters necessary for successful automated tracking. There are 2 crucial parameters. The first one is the average cell diameter. which can vary from a movie to movie and therefore needs to be measured for each movie separately. And the second important parameter is the positions of cells in the very first movie, so that the algorithm would know which cells to track. Apart from these two crucial parameters, you will also have the opportunity to enhance the contrast of the green fluorescent channel and to change the patch size if necessary. The meaning of these parameters will be explained later as we progress through the pipeline of this preparation window. So, to begin, push button 1A. One more pop-up window appears with the first frame given in green fluorescent channel. The possibility of changing the contrast was implemented solely for the user's convenience. The check-in algorithm doesn't need this. It will still be using the original non-enhanced images anyway. The reason is that in some movies, the green channel is so low contrast that the outlines of the cells are barely legible by the naked eye. And this can cause inconvenience as the user is supposed to monitor the progress of checking visually in real time. So to adjust contrast, you need to play with the slide bar provided. And once you're happy, just press save. But you know what? Our current movie is one of the Mohammed's high quality movies, and we obviously don't need any enhancement here. It looks quite fine already. So I'm bringing the slider back to zero position and just pressing save. Okay, now we are back in the preparation window. Now comes the time for the cell diameter measuring. So let's push this button and we are in a new window. Here you can see the green fluorescent frame in this, and you can actually use this slider to scroll through all the green frames of the entire movie. So the goal of this window, the goal of this step is to measure the cell diameter and the cell patch size also. So to begin, you need to left click on any cell, try to click as close to the center as possible. And the red circle and the yellow square appear around this cell. What does it mean? The diameter of the red circle is equal to the average diameter of the cell, which will be passed to the tracking algorithm. The size of the yellow square is equal to the patch size, which is the second parameter the algorithm needs to know. Now you can adjust both parameters by using slide bars. Let's start with the left slider, which allows you to play with the cell diameter. As you can see, you can immediately notice that the slide bar is programmed in such a way that whichever value of the diameter you set up here, the ratio of the square side to the diameter cannot be less than 2.4. Otherwise, the tracking algorithm will break apart. So the square is changing automatically to meet this requirement. You can click on other cells and the frame as well to check that you set up the size correctly. Now the question is, what is the right size of the red circle and of the red square? The main thing you need to aim for is that the patch size is big enough to incorporate the whole body of any cell. The diameter of the cell represented by the red circle is not so crucial. As you can see from the picture, let's take this cell, for example. This cell is a bit too long to fit into the red circle, and this is absolutely fine. To make sure that your choice of these two parameters is correct, scroll through the frames and keep left-clicking on the cells you encounter on the way. When you see, for example, if you see some especially long cell like this one, you can click on it to check that it does fit into the square. Maybe I should make a diameter a little bit bigger. So once finished, and so you can go through every single frame if you wish to do so. And after that, you need to click Save button. But we haven't discussed the right slider yet, which says patch size. What do we need it for? As I just pointed out, the ratio of the patch size to the cell diameter shouldn't be less than 2.5. But the thing is that it can be bigger than 2.4. And that's exactly what the right slider can do. It helps you to increase the patch size, thus making the ratio bigger than 2.5, 2.4. Let's get back to one of those. Uh-huh. So let's play with this. As you can see, I can increase the size of the square without affecting the red circle. But if you make this square too small, again, the ratio shouldn't be less than required. Okay, so let's do it like this. Mhm. Why do we need this feature? The answer is that it can be useful for the movies, especially new movies, where the cells make really big jumps. And it happens quite often in these very new movies taken by the new microscope. The idea is that the bigger the patch is, the less likely the algorithm is to lose the wildly jumping cell. The perfect ratio in this case can be found only through experimentation, though. In our case, we are dealing with old Mohammed's movie where the big jumps don't occur very often. So I'm getting back to initial size now. Maybe just in. And after that, I can push button save. So now we are in the preparation window again, and it's time to perform our very last step, assign initial cell positions. Let's click this button. So what you can see here, this is the very first frame of our movie from which the tracking will start. So now you need to choose how many cells you want to check. To mark the cells which you need to click, you need to click on them. Try to click in the very center, as close to the center as possible. So you can click on some subset of these cells, on 2, 3, or 4, or you can click on all the 8 cells. It doesn't matter. The algorithm will be able to process any case. But in this tutorial, I'm going to click only on one cell because the more cells in the tracking algorithm has to track, the slower it becomes. And my old desktop is not powerful enough, unfortunately, to cope with many cells. It slows down quite dramatically, which would be very annoying for this tutorial. But if your machine is more modern and more powerful, and especially if it has at least one GPU, everything will be working fine. So I'm clicking now on this cell and press the save button. Now we are back in the preparation window, and to finish the process, we need to push this button. We are now back in the main window. You can see some useful information about our movie here. So we have cell diameter here, page size, initial number of cells is 1. These are the parameters we just assigned in the preparation window. So now everything is ready for tracking. Let's push execute button. It takes some time for the algorithm to load the models, which are the trained convolutional neural networks for tracking and segmentation. So let's wait a bit. We are now back in the main window. You can see some useful information about our movie here. So we have cell diameter here, page size, initial number of cells is 1. These are the parameters we just assigned in the preparation window. So now everything is ready for tracking. Let's push execute button. It takes some time for the algorithm to load the models, which are the trained convolutional neural networks for tracking and segmentation. So let's wait a bit. So the automated tracking has started. Your task as the user is to monitor the process in this middle window, which is called current frame. And if something goes wrong, you need to stop the algorithm, navigate to the frame where the error happened, and use one of these 4 provided tools to make corrections. After that, you can relaunch the algorithm, the tracking once again. By the way, the pause button can be used not only in the situations when you spotted a tracking error and therefore want to stop to be able to make corrections. Sometimes, especially when the movie is very long and contains many cells in each frame, you might get tired of the constant monitoring and therefore you might have a lapse in concentration. In such cases, it's a good idea to pause the tracking and look through the tracked frames very slowly and carefully. Let's model this situation. Let's suppose that I've been watching the progress in this window for a long time, but then at one point I got a feeling that, oh, I lost my focus. What do I need to do? First, you need to pause the tracking by pushing this button. Then press the button, flashing button display result. It will display results, tracking results in the middle window. Now you can use the slider to go through each tracked frame and check them. If everything is fine, you can just relaunch tracking by pushing execute, and the tracking will resume from the frame where it was stopped, namely here. By the way, if you feel really tired or just don't have the time to finish the whole movie in one go, you might want to interrupt the tracking completely and leave it for another time. All you need to do in this case is to push button pause and then exit button. The tracking results will be automatically recorded, and next time when you choose to come back to the movie, the tracking will restart from where it was left off. In this tutorial, however, we will have to do it at one point, so it will be demonstrated later. But now I want to resume tracking. So I'm pushing this button. Let's learn now how to correct tracking errors using these tools. If you spotted one of these tracking errors while monitoring the current window, you need to pause, then wait until the display result button starts flashing, press it, and now you need to navigate to the frame where you spotted the error, which you want to correct. The frame which needs correction should be positioned here in the current frame window. We need to master all the 4 correction techniques, so let's start with edit division tool. No misdivision happened here, of course, but let's pretend for the learning purposes that it did happen in this current frame. The magenta cell was supposed to split into the 2 cells, we call them daughter cells, but the algorithm failed to detect the event. So let's activate edit division tool by pushing this button. The button Save Division Edit starts flashing, but we are going to ignore it for a while. We are going to push it when the edits are finished. Remember that once you activated one of these editing tools, there's no way back. You can't change your mind because all the tracking results after this frame where you stopped get deleted immediately, and you simply have no option but to proceed with your corrections. So be careful. Note that when editing divisions, you will have to use both current and previous frames. This is actually the main reason why the previous frame window is needed. So now that we activated this mode, algorithm knows that you are going to manually add a misdivision and expects you to give 2 pieces of information. The first piece of information is who is the mother cell, and the second, where are the both daughters located, where should their centroids be. The mother cell is now in the previous window, in the previous frame window, and the daughter cells are in the current frame window. To inform the algorithm of who the mother cell is, you left-click on the magenta cell in the previous frame. Now the algorithm knows that the mother is the magenta cell with the identity number 1. Bear in mind that when clicking on the mother cell, you don't have to worry about the precision of your clicking. Just click somewhere inside the body of the cell. This should be enough. But try not to get too relaxed, of course. Be careful not to click on the background. The next step is to mark the daughter cells. We do it by left-clicking on both daughters in the current frame. But this time, it's important to click as close to the daughter's centroids as possible, because if you click too carelessly, it might lead to the segmentation errors, which would be quite annoying. So I'm clicking on both daughters, on the centers of the both dots, and we are done. After that, we save division edits and relaunch the tracking algorithm again. After a while, you see the following picture. The magenta mother cell disappeared and two new cells came to existence instead. The orange daughter 10 and the yellow daughter with identity number of 11. The division can also be clearly seen in the lineage tree. The magenta branch has split into two sub-branches corresponding to those orange and yellow daughters. You may be wondering if there are any pitfalls here you should be aware of. Yeah, there is one thing you should bear in mind. You can correct only one division in the current frame. The editing tool is not programmed to tackle more than one division per frame. It will probably be implemented in the future. So now you know how to manually correct misdivisions. Let's move to the next technique, which is called edit IDs. Again, we need to pause tracking, then display results, and navigate to the frame where we detected the ID swapping. Cell ID swapping may happen when two or more cells get very close to each other. This is the soft point of any tracking algorithm, not only the one which is utilized here. We have only two cells available in this tutorial movie, so let's play with them. Let's pretend again, just for the learning purposes, that the two cells, orange and yellow daughters, have swapped during automated tracking, and we want to correct this. Let it happen, let's say, in this frame. What we want to do in this frame is that we want to swap the IDs of the two cells. We want the yellow cell to become orange and vice versa. So let's activate Edit IDs mode. We are now in the editing mode. Remember, this is a point of no return, as all the tracking results in the frames after the current one have just been deleted. And you just have to start editing even if you change your mind. So be careful about it. So now that we activated the Edit IDs mode, the program is waiting for two pieces of information for each cell we are going to edit. First, the ID of the cell, and second, its new position or its new centroid. The idea is pretty similar to that of a division editing. You mark the ID of the cell in the previous window, in the previous frame, and you mark its centroids in the current frame as the second step. Let's start with the yellow cell in the current frame. We want to make it orange. What exactly do we need to do? First, we need to left click on that yellow cell in the previous frame. The algorithm knows now that the ID is that of the yellow cell. Remember, just like before, you don't have to worry about the precision of your clicking when you need only the ID of the cell. I deliberately clicked quite far from the center of the cell to show you that it doesn't matter. Second, left click on the centroid of the orange cell in the current frame. The algorithm knows now that the yellow cell centroid needs to be where you clicked in the current frame. Repeat the procedure for the second cell. We want the orange cell to become yellow cell display. So here I click on the orange cell. Now the identity is known as 10, which is identity of orange cell. And now I click on the desired centroid of that cell in the previous frame. So now we are ready, and we need to close the editing mode and resume tracking. The tracking will resume from the current frame. That is the frame where you have just made ID corrections. Now you can see that we did achieve what we wanted. The IDs of our two daughters has swapped. But of course, it didn't affect the lineage tree. You just can't see ID swappings here. Note that this editing tool, unlike the previous one, doesn't have any limitations concerning the number of cells you can edit in the same frame. You can correct IDs of multiple cells in current frame simultaneously, as we just did for two cells. Also, you can edit only one cell if needed. Now we know how to edit ID swapping, and now is the time to move to the next technique, add cell. Again, let's pause the algorithm, let's pause the tracking. Now display result. And we need to put the frame, which is where we are going to do our editing, in the current frame as usual. What do we need this technique for? Sometimes a new cell may appear in the field of view out of nowhere. As the tracking neural network hasn't been trained to detect new cells, you need to add that new cell or probably multiple cells manually. Let's suppose, for learning purposes, that we want to add, for example, these two cells in this frame. All we need to do to achieve this, need to activate the mode, which is called add cell, and just click on the centroids of these two cells. That's it. And after that, push save button and relaunch the tracking once again. After a while, you will see that two new segmented cells appeared, the green and the blue one, with the identities A and B. And two new branches corresponding to these new cells came to existence in the lineage. Note that you can add as many cells at a time as you wish in the current frame. Just click on the centroids and push save button. That's it. So now we have only one technique left, which is remove cell. Why do we need it for? The thing is that cells in a movie can die or leave the field of view. In this case, you need to remove them manually again because the tracking neural network we utilize here hasn't been trained to tackle such events. So to show you how this tool works, I'm going to remove one of the daughters in this cell, in this movie. So let's go through this procedure once again. First of all, we need to pause tracking, then display result, and navigate to the frame where we are going to make these corrections. So as I just said, I'm going to remove one of these daughters, maybe orange one. So this technique is very simple for the user as well as the previous one. All you need to do just to click on the remove cell button. It activates the editing tool. And just click somewhere on the body of this orange cell which you want to delete. And then save button. And again, we're launching our tracking. Mhm. After a while, you will see the following picture. The orange cell has disappeared, and the orange branch corresponding to this orange cell stopped growing. Note that you can remove as many cells as you wish in the current frame. Just click on each of them and then push button save. So now you know how to use all the four correction techniques. And you may start wondering if there are any pitfalls you should be aware of. Yeah, there is one thing you should bear in mind, not to break the whole step 3. Namely, when pausing tracking for manual corrections and relaunching it again, you should never go back in time. And by going back in time, I mean that if you have made corrections in frame 10, for instance, the next correction should be only in frame 11, 12, and so on, but never in frame 9 or earlier. In other words, you can only proceed forward in time with your corrections, not backwards. This is the way this window has been programmed, and it was done for the sake of speeding up the process of editing. But unfortunately, removing this inconvenience has led to another inconvenience, namely the fact that you cannot go back in time now as a result. You might ask, what do I do if I still need to go back? It can, for example, happen due to the lapse in concentration when you realize all of a sudden that you failed to spot an error in frame 9, but it's too late now because you have just corrected frame 10. In this case, you need to interrupt the session completely by pushing pause and exit buttons and relaunch DeepKymoTracker once again. Let's do it now and see how it goes. So I already pressed pause button. Now display results. And let's suppose that you did it during monitoring the execution, and all of a sudden, going back through the frames of the movie, you realize, oh my gosh, I made a mistake here, but I can't correct it now because it's already too late. So all you need to do, you need to exit. By the way, before we push this button exit, let's discuss this button. We haven't discussed it yet. Create final movie in Excel file. Of course, this button is designated to be pushed after the movie is completely finished, when it's tracked to the very end. But sometimes, in some cases, you might be interested in the output even when the movie is not finished. So it's optional. It depends. It's up to you whether to push this button before exiting or not. I'm not going to push it now. I'm just exiting. So I'm launching step 3 once again. And here we are in the same step 3 window. So we have interrupted execution now because we want to correct the error which happened before. But as I mentioned earlier, we might also want to interrupt execution if you don't have the time to monitor the progress of the movie to the very end, and therefore want to leave it for another time. So now we are back in the window of step 3, and I want to go back to our movie. I want to open it. So let's push this button. You notice that a new folder has been created here, which is called Tracked Movie Tutorial. That's where the output is, by the way. But just as in the very beginning, we now need to click on One Well Movie Tutorial. Now we have a message here saying that the movie has been partially tracked. So we are pressing OK. And here we are. We have the same movie we just left. So now we can, now we are new session actually. And now we can go to any frame and start corrections. But remember that all the frames after the current one will get deleted once you activate one of those 4 corrections. So if there were any other corrections in the following frames, they will all be deleted and you will have to correct them once again. So the conclusion concerning this pitfall could be rephrased as follows. You cannot go back in time with your corrections if it is the same session, but you can if it's a new session. The same is true for the case when movie has been fully tracked and you want to get back to it for some reason. If you click on One Well Movie in this case, you will get a similar pop-up message with the difference that the phrase will be the movie has been fully tracked instead of the movie has been partially tracked. You press OK on this message and you will see the whole tracked movie and you can edit it if you need to do so. I'm not going to edit anything here because there's no point in it. You already learned all the editing tools. So now let's wait until the tracking is finished. So the tracking is finished. And now we can push this button to create final outputs and Excel file. Now the output folders have been created, and now is the time for us to have a look at the output. We are now on the desktop of my computer, and here is my DeepKymoTracker folder. I'm opening it now and open the subfolder called Movies. Here you see the collection of the movies you've processed using the DeepKymoTracker. We are interested in a movie called Tutorial, so let's open this folder. Apart from old familiar names, One Well Movie Tutorial and Raw Movie Tutorial, You may notice the new folder here, tracked movie tutorial. That's exactly what we need. That's where the output of DeepKymoTracker sits. So let's open this folder, and you will find loads and loads of information here about our movie and about each particular cell. So the first folder is called helper folders, not for user, and the name speaks for itself. These are folders. You can have a look inside this folder, but I'm afraid you won't find anything interesting here. These are files and folders which are used specifically by the program, so you don't need them. Then let's start with a video file, lineage movie. This is the lineage movie you are pretty familiar with. And now, if you prefer the still lineage, you can click on this image, and it gives you the final lineage tree of the tracked movie. Then, the next thing is to discuss these folders. You may notice that there are 3 folders here with pretty similar names: tracked bright field channel, tracked green fluorescent channel, and finally tracked red fluorescent channel. Let's have a look inside green fluorescent channel. Here you can see pretty familiar frames. These are frames of our movie given in natural size, which we used during the tracking. You, of course, remember these images. Here they are. They were in the middle window and in the previous frame, of course. So let's close this folder. And if you have a look inside bright field channel, you can see again the frames of the movie in their natural size with segmented interact cells, but this time they are given in bright field channel. And the same goes for the folder named tracked red fluorescent channel. Here you can see the same picture, but given in the red fluorescent channel. Let's discuss this folder, segmented binary, what it is. You can see it. This is the binary segmented version of your movie, where each cell body has an intensity of 255 and the background is black. Yeah. There is another folder which is called segmented color. This time it's the segmented image, segmented version of your movie, of your tracked movie, but this time each cell has its own color assigned to it during the execution. Okay. So these were all folders and files which are created automatically during execution. So they don't need the user's intervention. They don't need you pushing some button or something. But as for the folder which is called results per cell, it's only created when you push this last button. Remember this button which is called create final movie in Excel file. You remember that I pushed this button before exiting. So let's have a look inside this folder. You will see a number of subfolders with pretty familiar names. These are the identities or names of the cells we have tackled in our movie. So cell 1 was the magenta cell, the mother cell, which gave birth to 2 daughters. Cells 1, 0 and 1, 1 are the orange and the yellow daughters of this cell. We created them artificially because I wanted to demonstrate you how to use the misdivision editing technique. Finally, you have 2 folders called A and B. These are the names of the cells we added artificially when I was demonstrated you the technique, editing technique called add cell. And you can see these 2 branches corresponding to these 2 cells. So let's have a peek inside one of these folders. Let's have a look at this yellow daughter 1, 1. Once you open this folder, you will see again loads and loads of all sorts of information about this particular cell. Let's start with the visual information. Visual information is stored in these folders, and the numeric information is mostly in the Excel file. So let's have a look first at this visual information. So the first three folders, they have pretty similar names. Cell 1, in bright field patches, in green fluorescent patches, in red fluorescent patches. Let's open this folder. You will see the patches cropped out of each frame during tracking in their natural size. And the background is black, but the body of the cell is cropped out of green fluorescent channel this time. So I can magnify it. So these are the outlines of our cell 1 in this particular frame. So similar you can have a similar picture if you open bright field patches. Again, the background is black, but the body of the cell is cut out of a bright field channel, and so on. The same applies for the folder with name cell 1 in red fluorescent patches. So there's also a folder which is called cell 1111, oh, cell 11, sorry, I'm tempted to call it cell 11, in segmented patches. So here you can see just binary segmentations of this particular cell given in these small patches. Finally, you also have a folder which is called cell 11 in segmented frames. What are these? These are the segmented frames of our movie given in their natural size. But there's only one cell segmented in each frame. This is our current cell 1111. All the other cells are ignored in every frame. So sometimes you might want this picture. Finally, let's open now the Excel file. Excel file as usual contains a lot of numeric information organized in columns. So let's go over these columns. The first column is called frame, and this is the frame numbers where this yellow cell 11 was present. You remember, of course, that the yellow cell is one of the daughters of the magenta cell, and it was born in frame 3390 when I was showing you how to edit periodic divisions. So this was the mother cell 1, and this no 1 0 1 1 0 cell 1 is the yellow cell. Sorry. So the next two columns, Cx and Cy, are the centroid coordinates of that yellow cell in each frame. These coordinates are given in pixels. The next three columns are area, perimeter, and circularity of this cell given in each frame and in pixels, of course. Well, then the next four parameters, the next four columns, give you the parameters of the bounding box of that cell in each frame. The first two parameters are called X box and Y box. These are X and Y coordinates of the top left corner of that bounding box. The last two parameters, W box and H box, are the width and the heights, respectively, of the bounding box. All the four parameters are given in pixels, as usual. Finally, let's move to the last three parameters. These are average intensities of the cell body given in different channels. So this is the average intensity of the cell body given in fluorescent image. This was calculated, by the way, from the patches. Let's have a look once again at these green fluorescent patches. So this is one of the patches. So the average intensity of the cell body in the green fluorescent channel was calculated using these patches. Now let's get back to our Excel file. So apart from this numerical information, you're also given three diagrams for the area, the perimeter, and circularity of your cell, which is 1 currently. As usual, the numbers given on x-axis are just the numbers of frames, and the values given on y-axis are respectively the area of the cell, perimeter, and circularity in the last diagram. These diagrams can be very useful in the cases when you want to spot a segmentation error, but you are sort of lazy to go through every single frame of the movie. When segmentation errors happen, usually it immediately affects the area or perimeter or circularity, or I mean all of these three parameters. You can immediately see that there are some outliers. All of a sudden, the area of this badly segmented cell becomes either very good, either very big, or on the contrary, very small. This is a true indication that something bad happened to the segmentation. So it can be really helpful. These diagrams can be really helpful in this case.